Section 2.8, Chapter 4, Chapter 5, and Section 6.2 in preparation for the midterm exam. So the questions are such a way that they are distributed evenly. Let us take a look at question number 1, for instance. This is from section 2.8. The question says, if f inverse of x is equal to this. Of course, gentlemen, we know that this function is not one-to-one because this is a parabola which is facing up. So, but if you look at it here, there is a restriction on the domain which made it one-to-one. In other words, we are taking a look at if we have a parabola, we don't know what is k. K may be positive or k may be negative. So the parabola is more or less like this one. So when we are talking about x less than or equal to 0, we are talking about this part. And then here we have x greater than 0. So you will agree with me that since we are interested in only this part, the function is one-to-one. And as such, we can find the inverse for this function. So here, gentlemen, the inverse is already given to us. So what do? Let us rewrite this one. We say here, f inverse of -1 shall be equal to 5. This is now representing, we're going to substitute x for -1, and then the y is going to be for 5 in this function. So therefore, what do we have, gentlemen? We have f inverse of -1. Here we get 3 into -1 all squared plus k, and that will be equal to 5. Now, what do we do here? We can solve for k because that is what we are looking for. We don't know what is k, so we cannot determine what is the function without knowing the k. So square both sides here. Take the square of this one. We have 3 into 1, so it's going to be equal to 3 plus k is going to be equal to 5. And clearly, when you take 3 to the other side, we have 5 minus 3, which gives us k to be equal to 2. So therefore, our function becomes f inverse of x now becomes equal to 3x squared plus k, which is 2. The question says we should find f of 3. We know one thing from the inverse of the function. We said f of x is always equal to y, and f inverse of y is equal to x, right? So here, the domain of the inverse function is represented by y, while the range of the inverse function is represented by x. So here we have the x. So what is going to be this one now? F of 3. So x is going to be representing the range now. So that is going to be 3 equal to 3x squared plus 2. So we are going to solve for x. And when we solve for x, that is going to represent f of 3. How do we do that? I take 2 to the other side. We say 1 is equal to 3x squared. And let us solve for x. X is going to be equal to, x squared is going to be equal to 1 over 3. That means x is going to be equal to plus or minus square root of 1 over 3, which we can write as 1 over root of 3 directly. Now the problem here is that we have plus or minus. How do I know which one to pick? Gentlemen, we have a condition from the beginning. We have less than or equal to. Now for simplicity, whenever we have less than or equal to, or less than, we take minus. And whenever we have greater than or equal to, we take positive. So here, gentlemen, since we have less than, we are going to pick negative. And then our x is going to be equal to, rationalize the denominator. We have root of 3 divided by 3. So what does it mean? It means f of 3 is equal to minus root of 3 divided by 3, which is our answer. Now, you can ask question here if something is not clear to you, gentlemen.
Doctor, how did you pick up the minus instead of the positive?
Okay, I will explain it to you more clearly. You see, when we say x is less than or equal to 0, you find k to be equal to 2. Then the graph is like this one. So the y-intercept here is 2, right? So here we are talking of only this part, right? We are talking of only the left part. And then the right part is deleted because we said x is less than or equal to 0. So for simplicity, we are talking about the domain of the F inverse is going to be the range of F. And then the range now, we take the minus because the domain is less than 0. So the range is also going to be less than 0. Does that answer your question?
Yes, thank you, Doctor.
All right. Okay, I have Mr. Walid raising up his hand.
Yes, Doctor. Doctor, could you explain the part when you picked 3 as the answer of the flipped of the inverse function?
Okay, yes. We have here f of 3. Let's say this is equal to, for example, y. You don't know what is y, but you are looking for y. Now, if we take the inverse of this, that means 3 is going to be equal to f inverse of y. Of course, we are talking about the f inverse. Don't worry whether we call it y or k. We are talking about the f inverse. F inverse is equal to 3, and that is why we substitute 3 here.
Okay, very clear.
Is that clear? Yep. Mr. Tamir, your question?
Can you repeat, Doctor, this point? I don't understand.
Okay, let me write again.
I don't get it too.
Okay.
Please.
F of 3 is equal to k. Let's say f of 3 is equal to k, or let me call it b for m, for example. We are looking for m. We don't know m. But the inverse of this function exists, right? So what is going to be the inverse? 3 is going to be equal to f inverse of m. Do you understand this one?
Okay, yes.
If you do not understand this one, just relax, Yashik. You have f of 3 equal to m. So take the inverse of the inverse, f inverse of this one, and then f inverse of this one. So here, this we go with this one. So 3 is going to be equal to f inverse of m. Is it clear now?
Not clear.
Yeah, because f inverse of the inverse is going to give you the original function, right?
Yes, yes.
All right. Abdul Malik, you have a question?
Yes, Mister. How is f inverse of y is equal to 3x squared plus 2?
F inverse of y equal to 3x plus 2. Where? Oh, okay. This is the question. Maybe you did not look at the question, Abdul Malik. F inverse is equal to this, right?
Yes.
So what did I do? I only find k here, and I remove this k, and I put k, which is equal to 2. So that is why you get the same thing. F inverse and F inverse. I just repeat it again.
Okay, I got it. Thank you.
It's clear, right?
Yeah.
Okay. All right, gentlemen, let us continue. Now, let us look at this beautiful question. Here, the question says if we have y is equal to 2 to the power of a minus 2 to the power of b minus cx, is the equation of the adjacent graph, then A plus B plus C is equal to what? Now, we have more than to answer this question. Session administrator, where is this? Okay, so we have more than one way to answer this question. We can substitute the points. For example, we can see that there is x-intercept, which is 1, 0, and there is y-intercept, which is going to be 0, -3. We can substitute these points, and when we substitute this point, gentlemen, what do? We can get the equation we are looking for. But that is not the best way to answer the question. What is the best way of answering the question, this question? The best way is to know the equation of each of the graph of exponential. Let me give it to you. Number one, if we have an exponential, we have a graph like this one. Okay, when the graph is increasing, this is 0, 1. What is the equation, the general equation for this? It is y equal to a to the power of x minus h plus the horizontal asymptote. Now, the second graph is decreasing graph, and that is 0, 1 again. Here, because it is decreasing, that means a is going to be between 0 and 1. So we have y equal to 1 over a all to the power of x minus h plus the horizontal asymptote. Now, each of them can be reflected. For instance, gentlemen, when you reflect this one here, the graph is going to be down here. Now, reflection across the x-axis, we're going to have y equal to minus a x minus h plus the horizontal asymptote. Now, when you have the reflection of the above here, it will be like this one. So this point is 0, h minus 1. Also here, it is 0, minus 1. This is y equal to minus 1 over a to the power of x minus h plus the horizontal asymptote. Now, what do you do here? You have to look at one of the shape. Let me number them for you. 1, let's say 2, this is 3, and gentlemen, this is 4. Now you have to look at the shape that looks exactly like your graph. You will agree with me that the shape is the case number 4. So now, the case number 4 is going to be like this one. I will write. We have y equal to minus 1 over a all to the power of x minus h plus the horizontal asymptote. Gentlemen, I am giving you the general way to answer the question. In case, in this question, you are given the 2 here and 2 here. What if I'm not giving anything and I want to still find the equation? That is what I want you to understand. Then we are going to learn the shortcut also. But for now, let us concentrate on the general. So here, gentlemen, we know what is the horizontal asymptote. The horizontal asymptote here, it is y equal to 1, right? So allow me to rewrite. We say y equal to minus 1 over a to the power of x minus h plus the horizontal asymptote, which is 1. Then we need to find h. How do we find h? Please pay attention. To find h, gentlemen, what do? Here we have y equal to 1. What is going to be the next integer value of y on the graph? We have either y equal to 2 above or y equal to 0 below. But unfortunately, there is no graph above. So cancel this one. There is a graph below. So we have y to be equal to 0. If y equal to 0, what is your x? That is what we are looking for. And this is going to be the point. 1, 0. So gentlemen, I repeat. When y equal to 0, my x is equal to 1. And this your x is equal to 1, it is always represented by h. Always represented by h. So let us go here, and instead of putting h is going to be equal to 1 here. So I make it 1. I did not change anything. So we have the horizontal asymptote to be 1, and we are also have h to be equal to 1. Now what do I do next? I need to find what is the base. Here, the question gives us the base to be 2. Is it really 2? I don't know, but I can find out. To find the base, we can use additional point here. You can see this point here. When x is equal to 0, y equal to minus 3. Let us substitute this point here. So we say 0, minus 3. So y is minus 3 equal to minus 1 over a, all to the power x is 0. So I put minus 1 here, plus 1. Now please simplify. You see, we can take this one here. We are going to get minus 4 to be equal to minus. Now, if you take the reciprocal of this, we are going to get a to the power of 1. Now, minus, we go with minus, and that means our a will be equal to 4. Now, if the base is equal to 4, let me rewrite the function, please, gentlemen. Let us rewrite the function. This is our equation. I want to rewrite this one. So we say y is equal to minus 1 over a, that is 1 over 4, to the power of x minus 1 plus 1. This is supposed to be the equation we are looking for. Unfortunately, it is written as a base of 2 here. Can we rewrite? Of course we can. How do we do that? We say this is going to be equal to minus 2 to the power of minus 1 as the base. And then we have x minus 1 and then plus 1. Now let us multiply this one here with the power. So this is give us minus out. Then we have 2 to the power of minus, sorry, this is 2 to the power of minus 2. I forgot. So here we have minus 2x and plus 2, and then plus 1. But if you look at the equation, there is no 1, there is 2 to the power of a. So in other words, we can write this one as 2 to the power of h0. So now if you compare the two equations, when you compare, we can rewrite it more beautifully. We say y equal to 2 to the power of 0 minus 2 to the power of 2 minus 2x. Now let us compare this one with our equation. That we have a. So a will be equal to 0. So therefore a is equal to 0. Then we also have b. B shall be equal to 2. B is equal to 2. And what is c here? Because there is a minus c and there is minus 2, that means c will be equal to 2. And the question says the sum. So a plus b plus c will be equal to 4, gentlemen. And that is our answer. Questions, please. So this is the way, the standard way. We can also solve the same question by a shortcut method by the concept of substitution. Now, let us try to substitute here. By substitution, how do we get the answer? But this substitution, we can use it because we are given this. If we are not given the base, we cannot be able to use the method of substitution. So by substitution, what do we have? We have y equal to 2 to the power of a minus 2 to the power of b minus cx. So now let us start with this point here. The first point, we have 1, 0. X and y. If we substitute, we get 0 equal to 2 to the power of a minus 2 to the power of b, and then we have 2 to the power of a minus.
Doctor, I think you should use the other point where x equals to 0.
We are going to use both of the points. Just relax. So this is going to be equal to minus x, right? But we know something. What do we know? You see, this one is a constant. This constant represents the horizontal asymptote. So the horizontal asymptote is equal to 1. Y equal to 1. You need to understand this one. So in other words, I can rewrite this one to be 0 equal to now 1 minus 2 to the power of b minus x. You can break it into two parts, or you can wait here, stop here, and continue with the second point. What is the second point? The second point is 0, minus 3. When I substitute this one, what do we get? We have x and y. So y is minus 3 equal to 2 to the power of a. Allow me to write it as 1 now. Minus 2 to the power of b. And x is going to be equal to 0. So we have 2 to the power of b only. Now, when you bring 2 to the power of b to this side, we say 2 to the power of b is equal to 4, which is going to be 2 to the power of 2. Because the base is the same, lazim, the power must be the same. So we have seen that here b is equal to 2. Now that you have b to be equal to 2, substitute here. B equal to 2, substitute here. Sorry, this one is c, not x. Substitute here. Then we have 0 equal to 1 minus 2 to the power of, gentlemen, 2 minus c. Now, we can enjoy this one by rewriting. 1 is equal to, take 1 to the other side and take 2 to the other side. We can say this is going to be 2 to the power of 2, multiply, gentlemen, by 2 to the power of minus c. Now, divide both sides by 2 to the power of 2. This is going to give you 2 to the power of minus 2, which is going to be giving you 2 to the power of minus c. So because the base is the same, lazim, the power also should be the same also. So that means c, again, is equal to 2. And then a plus b plus c again is equal to 4. Because we know that a is equal to 0. So we can use substitution, but as I explained to you earlier, writing it in standard form is the best way. Because if, for example, in this question, if I don't give you what is the base, if you are not giving these two here, there will be trouble. Do we have questions, gentlemen?
Doctor?
Please, if you have a question, I will prefer you to raise up your hand so that we're going to be more orderly. Yes, Ablaziz.
Yes, doctor. Isn't C supposed to be negative 2?
No, because there is negative, ya Sheikh. شوف هنا. Minus 2 equal to minus C. The minus we cancel with minus. Now?
I mean in the first example, and the first way you solved the question.
The same way. شوف هنا. What did you do? You say here, look at this one. Take this one. 2 minus 2c is equal to 2 minus 2x is equal to, from the question, you say 2 b, right? B,
Yeah, B minus cx.
Minus cx. You know b to be equal to 2 already. So make this one 2. This we cancel with this one. So you see minus 2x is equal to minus cx, right? So what does it mean? It means minus 2 is equal to minus c, right?
Yes.
So that means c will be equal to positive 2.
Okay, thank you, doctor.
Abdul Malik.
Yes, mister, sorry for disturbing, but in the second method, how did you know that a is equal to 0?
A equal to 0 because we mentioned this one earlier, that this is the horizontal asymptote, right?
Right.
And the horizontal asymptote is the line y equal to 1. And for line y equal to 1, we have 2 to the power of a. So 2 to the power of a is equal to 1. So 1, you can write it as 2 to the power of 0. Now?
Yeah, but why? How did you know that y is equal to 2 to the power a?
What? No, maybe the question you should be asking, how do we know that 2a is equal to 1? Maybe. Is that your question?
Sorry again?
Maybe what you want to ask is, why is 2a equal to 1?
No, this is what I know this step. No problem. You keep going. Okay. Thank you.
All right. Okay, gentlemen, let us go to number 3. In number 3, here it says the graph of this function is below the x-axis on the interval. Which interval is the graph below the x-axis? We can answer this question in 2 ways. One, by algebraically from 0, 0, 1. And then using the idea of 0, 0, 2 to complete it. The second idea is by graphing. By sketching the graph will take us more time. So let us try to solve it by algebra. When we say below the x-axis, what does that mean? That means the value of y is going to be less than 0, right? When you have a 2-dimensional coordinate system, we say here it is below the x-axis, right? That is when y is less than 0. And then we can say above the x-axis. That means y is greater than 0. So we are interested in below the x-axis now. So that means, gentlemen, we're going to say 1 minus 2 multiplied by e to the power of minus absolute value of x. This will be less than 0. Let us solve this inequality. Now, the idea of solving the inequality, you will agree with me, this is from 0, 0, 1. So let's try here. Okay, let's say minus 2 multiplied by e to the power of minus absolute value of x is less than minus 1. We can divide both sides by minus 2. So we have e to the power of x, absolute value of minus absolute value of x less than 1 over 2. Is it going to be less than now? No, because you divide both sides, gentlemen, by minus 2, then we are going to change the sign of the inequality, right? To greater than, if you remember. So now, let us take the lane of both sides. When we take the lane of both sides, we are going to get minus absolute value of x to be greater than the lane of 1 over 2. Now, what do? Let us multiply both sides by minus again. So we're going to get absolute value of x less than, gentlemen, minus lane of 1 over 2. I change the sign of the inequality again because we multiply by the minus, right? Now let us apply the power property of logarithm. Take this one to the power. Here we have absolute value of x less than lane of 2, right? Because it is going to be 1 over 2 all to the power of minus 1, which is going to be equal to 2. Now, we know this property from 001, section 1.8. When we have, this one is what we call the central inequality. This means minus lane of 2 will be less than x, which is going to be less than lane of 2. And that means the graph is going to be below the x-axis on the interval from minus lane of 2 to lane of 2. And that is our answer by algebra. Questions, please.
Allah,
Okay,
Mr. Thank you very much. I was having trouble with questions like this, but I understand it very clear now.
Alhamdulillah. Okay, gentlemen, let us take a look at example number 4. The questions here says here for a real number x, the domain of the function, the domain of the function. Ordinarily, we can look at the domain without worrying about anything, but there is a problem here because we have a variable as a base. Now let us take a quick look at the definition of logarithm. It says when you have log base a of x, for us to call this one a logarithmic function, we say a less than greater than 0 and a cannot equal to 1. Then also we say and x here, which is the argument, x should always be greater than 0 before we can call it logarithmic function. So now we have to put all this one together to be able to find the domain, because there is a variable in the base. If there is no variable, then we don't need to worry about anything. So now, gentlemen, please pay attention, the domain. So the first one, I have to start with the base. X must be greater than 0 and x cannot equal to 1. That is what the base gave us. And then the second condition, and the argument, x minus 2 divided by 3 minus x multiplied by x minus 4, this should also be greater than 0. This should also, gentlemen, be greater than 0. Okay, now, this one, we know we can write this one in interval notation. We can say from 0 to 1 open, union from 1 to infinity. That is regarding the base. Now, regarding the argument, we can solve this one by the sign diagram, which is often called the critical value method. By the critical value method, we say the CVs. The critical values are the zeros of numerator and zeros of denominator. From numerator, we say x is equal to 2. From denominator, we have x equal to 3 and then x equal to 4. Now, we are going to draw a real number line. The real number line from minus infinity to infinity. Now, we have 3 critical values. So let us represent each of the critical values, gentlemen. Now, because we have strictly greater than, each of the interval is going to be open interval. Now, let us get started. The critical values are 2, 3, and 4. Now, which of the factor is giving us 2? We have x minus 2. Which of the factor is giving us 3? It is 3 minus x. And the factor that is giving us 4, it is x minus 4. Then, here we have minus, plus, plus, plus. And here we have positive, positive, negative, and negative. And here we have negative, 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 and positive. Gentlemen, here you may not necessarily use this method. You can use any of the method you have learned from 001. That will be perfect. So here we have positive here. That means minus multiply with minus, multiply with positive. That will give us positive. And here we are going to get negative. Here will be positive, and here will be again negative. We have the interval here to be greater than, strictly greater than. And when we say greater than, gentlemen, we are going to pick positive, right? So here we are going to pick this interval, which is positive, and also this interval, which is positive. So here, what do we get? We're going to get minus infinity to 2, union from 3 to 4. Now, what do we do, gentlemen? We have and here. If you remember in 001, when we are talking about set, when we say and, it means intersection. So now we are going to take the intersection of the two answers. The two set, the first one, 0 to 1, union 1 to infinity. And then take the intersection, gentlemen, with the second set, from minus infinity to 2, union from 3 to 4. Now, when we take the intersection, you will agree with me that we are going to start from 0, actually. From 0 to 1, union, gentlemen, from 1 to 2, union from 3 to 4. And that is our answer. Questions, please.
Doctor, how did you get the signs in the table you made?
That is, I mentioned here that regarding the sign, you have an option. All right. You can use the way I have done, or you can use the sign test you have learned in 001. Depends on what you have learned in 001. What I mean is this one. In 001, some students have learned this way. You have minus infinity, interval here is 2, you have 3, and you have 4. So the way some students have learned here, you have positive, positive by using a test value. Then here is negative, negative. And here we have positive, positive using test value. And here negative, negative. Whichever you use is going to be the same. Because maybe learning this one now may not be good idea for you because of the time, but I can explain to you. How do we get it? You see here, you are supposed to be a number inside this interval, and then use that number to test, and then you are going to know. For example, I can take x to be equal to 0 here. When I substitute 0, 0 minus 2 is going to give you minus 2, so that is why you get minus. If you substitute 0 here, it is 3 minus 0, that is going to be 3, that is positive. And if you substitute here, you say 0 minus 4, that is going to be minus 4. That is how you get negative. And that is how to get the sign. Is that clear now?
Yes, clear.
Okay, gentlemen, let us continue now.
Doctor,
now,
if you have a number instead of a variable in the base, should I take the domain to be greater than 1 and not equal, greater than 0 and
okay. Let me just go back to the same question. Let us assume, for example, you have the same question and base here. Let's say the base here is 2, for example. You don't need to worry about anything. This is going to be your domain directly. Does that answer your question? Okay. Yes, Muhammad Rasasis. Okay, Mr. Tamir, you have a question?
The zeros of the base always a and greater 1 and a
yes,
not equal to 0.
No, greater than 0 and not equal to 1.
Okay.
The base of the base is always greater than 0 and not equal to 1. Is it clear, gentlemen? Okay, now let us proceed. This is another beautiful question which combines section 4.4 and of course section 5.2. Here we are going to use change of base. A. Let us start with A. A here we have the square root of 2. So gentlemen, by the square root of 2 you can say 2 to the power of a half. Right? Now you will agree with me that this is actually change of base. That is going to be log base 4 of 9. I hope you understand this one. Change of base is if you have log of ax is going to be equal to the log of the argument divided by log of the base. So in other words, the base here, the log of the denominator is the base, and the log of the numerator is always the argument. Now please up here. Rewrite this one. This is going to be 2 to the power of a half. Now let us simplify this. I want to change the base to 2 here. So it is 2 to the power of 2 of 9. And I can bring the half here. I hope you agree with me. That is one of the properties of change of base. And then here, what do we have? What do we have? Some of you may be question, how did I obtain this one? Let me explain it better. We have log base 2 and the power is 2, right? So this power of 2, you can move it here to the power of 2, you can move it to the argument, which is going to be 1 over 2. Always the reciprocal. The rule is this. Log base a to the power of k of x is always equal to log base a of x to the power of 1 over 2, which you can write directly as 1 over k, sorry, which you can write directly as 1 over k multiplied by log base a of x directly. You can do this one. So this will be equal to what? This is going to be equal to 2 to the power of a half. I did not touch this one yet. And here we have log base 2 of 3. So now let us take this one and take it to the power. So here we have 2 log base 2 of 3 to the power of a half. Now the base here is 2 and the base of the log is 2. They will cancel each other. And then we have 3 to the power of a half, which is going to be square root of 3. So a is equal to root of 3.
Doctor, can you repeat the last?
Which one? Oh, it is a property of logarithm. The property of logarithm says if you have the base to be a, and then you have the power to be log base a of x, this is always equal to x. Why? Because this base and this base will cancel each other. So now, gentlemen, we have a. How about b? For b, we have 2 sine of e to the power of minus ln of 3 over 2 over pi. Now, I don't want the minus ln. Can I remove this minus by taking this to the power? Yes, we can do that. So we can put here ln of 3 over pi all to the power of minus 1. Let us close this. Now, to the power of minus 1 means we can take the reciprocal. So this is going to be equal to 2 sine of e to the power of ln of pi over 3. Now, we know this property. E and the ln, they will cancel each other. This is the same property I just explained now. So this is going to be equal to 2 sine of pi over 3. Sine of pi over 3, that means 60 degrees, right? What is sine of 60 degrees, gentlemen? The sine of 60 degrees is going to be equal to
root 3 over 2.
Oh, thank you. Root of 3 divided by 2. So here, 2, we cancel with 2. And again, gentlemen, b is equal to square root of 3. Now the question says a plus b is equal to this. So a plus b is going to be equal to root of 3 plus root of 3, which is going to be equal to 2 root of 3. Now, if I compare then with this, m root of n, therefore, m is going to be equal to 2, and n shall be equal to 3. The question is asking for the product. So m multiplied by n shall be equal to 2 multiplied by 3, which is equal to 6 as our answer.
Nice question.
Any question here, gentlemen? All right. Now,
are the questions you're explaining, are they from are they considered recitation?
No, these questions I'm explaining, they are old exam questions picked here and there. But what I have done, I have taken the old exam questions that are possibly on the I side. You get my point? So that we all going to enjoy, because if you have prepared yourself, it is just like a wake-up call that you are well prepared. And if you have not prepared very well, it tells you that you need to prepare more again.
It means A plus questions.
Let us look at this question here. Not necessarily A plus questions. Some of them are A plus mixed with B. And then also there is some C level questions here. Okay, now the question says the sum of the solutions. We know how to solve this type of question. The sum of the solution, here we have to write them to be the same base, because if they are not the same base, it will be difficult for us to be able to solve. Here we have a base of 3, which is good news. Here 1 over 3, and this is 9. So it will be better to change everything to 1 over 3 base, or 3 as a base. Whichever way is easier, it is better. So let us rewrite, please. Now apply the power property and bring these 2 here. We have log base 9. Now we can write it as 3 to the power of 2. And then we have 2 minus x all to the power of 2. Here we have minus, but here we have 1 over 3. So this becomes positive. And then we have log of 3, base 3 of 3 minus x equal to log base 3 of 6. Gentlemen, is there a question here before I continue? Yes.
How can you change third to 3? 1 over
third
3 to 3.
Okay, that is a property. That is a property.
The
okay, property is like this one.
Over or 2 power minus 1, right?
Yeah, 3 to the power of minus 1.
I get it. Okay, I get it.
Okay, that's good. Okay, now here we have the power to be 2 and the power here has to be 2. The 2 power will go with each other, because if you take this one up, it becomes the reciprocal. So this is going to be log of 3 of 2 minus x. Multiply, gentlemen, by 3 minus x. Why am I doing that? Because the base is the same, 3, 3. And this is going to be equal to log base 3 of 6. Now, because the base is 3 here and the base of the log here is 3, this we cancel with each other, one-to-one function. Now, open the bracket. If you open the bracket, what do we get? We get minus x with x, minus x with minus x. That will give you x squared. Now, minus x with 3, that is going to give us minus 3x. And then minus x with 2, and that is going to give us minus 5x. Now, we have 2 multiplied by 3, that is going to be plus 6, and this is equal to 6. You will agree with me that 6 we cancel with 6. So here, what do we have? We have x squared minus 5x equal to 0. Now, we factor x outside. So we have x minus 5 is equal to 0. Now, what is the solution? Here we have x equal to 0 or x is equal to 5. Are we going to accept the 2 solutions? No, because this log equation, to solve the log equation, one thing always comes to the mind: we must check our solution. Why do we have to check the solution in log equation? Because we say log base a of x, the argument x here should always be greater than 0. So now let us say check. Now if you substitute x equal to 0 here, we are going to get log base 9 of 2. If we substitute 0 here, we are going to get log base 1 over 3 of 3, and this is defined. So x is equal to 0 is defined. How about 5? If we substitute x equal to 5 here, we are going to say 2 minus 5, which is going to be equal to minus 3. The argument cannot be negative. This is impossible. So because we can find one impossibility, this is out. It is rejected. So we have only one solution. So therefore, the solution set is going to be equal to 0. Now the question asks for the sum of the solution. Therefore, the sum shall be equal to 0 as well. Is there a question here? Okay. Now let us move on to the next question, gentlemen. Number 7. Here the question says if x is equal to ln of k is the sum of the solution of the equation, then what is going to be k? Now, in other words, what we need to do is to solve this exponential equation. How do we solve the exponential equation? We have e to the power of x plus 6e to the power of minus x is equal to 5. Now, you will agree with me that e to the power of x is a fraction. E to the power of minus x is a fraction because it is going to be 1 over e to the power of x. Now, dealing with fraction is not something to play with. So what can we do to remove this fraction? We can multiply both sides by e to the power of x to remove the fraction. So here, what do? I will multiply the left side by e to the power of x. And then we have here ex plus 6e to the power of minus x. And this is going to be equal to 5 multiplied, gentlemen, by e to the power of x. So now, multiply this with this. We are going to get e to the power of 2x. Multiply this one with this one. And then we are going to get plus 6 only. And this will be equal to 5e to the power of x. Now, if you see what I'm saying, this equation is quadratic in form because we have e to the power of 2x, which we can rewrite as e to the power of x, and then take the 2 outside. Now bring this 5e to the power of x to the left side. It will be minus 5e to the power of x plus 6 equal to 0. Now, if we let, for instance, gentlemen, u equal to e to the power of x, therefore, what do we get? We're going to get u squared minus 5u plus 6. Why are we substituting this one? Just to make life easy, in fact. So, Ahmed, please, can you close your mic? Okay, now, let's factor, gentlemen. We have x minus 2 and x minus 3 to be equal to 0. So what do we have? Sorry, u. We are using u. That means u is equal to 2 or u is equal to 3. Now we know what is u. U is e to the power of x. This implies that e to the power of x is equal to 2 or e to the power of x is equal to 3. Take the ln of both sides. X is going to be equal to ln of 2 or x is going to be equal to ln of 3. These are the solution. The question says the sum of the solution. So sum, we have ln of 2 plus ln of 3. And then using the product law of logarithm, this will be equal to ln of 2 multiplied by 3, which is equal to ln of 6. But we need to compare this one with the sum of the solution. According to the question, the sum of the solution is ln of k, and that means k is equal to 6. Yes, somebody is raising up their hand. It's hard to reach. Mr. Raya?
Yes, Doctor. Don't we have to check about the values, ln 2 and
For
ln
the
3?
export? No, there is no need to check. If there is anything to reject about the logarithm, I tell you here, it is going to be rejected here. Because they are defined, then it is okay. And in exponential equation, usually you don't check unless it involves logarithm. And when it involves logarithm, if there is a problem here, you're going to see from the ln that it is going to be rejected. For example, you get ln of a negative number or ln of 0.
Okay, I understand now. Thank you.
You're welcome. Okay, let us look at number 8, gentlemen. Here the question says the wheel on a bicycle turns at k revolution per second when the bicycle is traveling at 30 feet per second. Now, let us try to understand what is given to us. When we are talking about the wheel, the tires of the bicycle, they are rotating at k revolution per second. That is angular speed, omega. And then the bicycle is traveling at 30 feet per second. That is the linear speed, v, denoted by v. Now, the question says if the diameter, so what are we given? We are given w, the angular speed. It is k revolution per second. We are also given the linear speed. The linear speed is 30 feet per second. And the question gives us the diameter. Diameter is 2r, right? And the diameter is equal to 3 feet. And what does it mean? It means the radius will be equal to 3 over 2 feet. Now we have all the information we are looking for. Then the question says, what is going to be the k? For me to find the k, that means I have to find the angular speed. We know the relationship between the linear speed and angular speed. V is equal to r multiplied by w. And this means w is equal to v divided by the radius. And what is the linear speed? The linear speed is 30 feet. Divide by the radius, which is 3 over 2. And this we can rewrite as 60 divided by 3, which we can write as 20, gentlemen, 20 radian per second. This could have been my answer, but unfortunately no. Why? Because this is in radian. Whenever we compute W, it is always expressed in radian. Why? Because the W is equal to theta divided by T. And this theta is always in radian for the formula to be valid. So now, if you look at the question, the K is in revolution per second. So we have radian per second. So we are going to convert this radian to revolution. So therefore, in revolution, what do we have?
Divided by 2 pi.
Yeah, just let me write it easier way. W will be equal to 20 radian per second. Now, the easy way, gentlemen, so that you don't make mistake, I tell you, because you do not want radian, right? So here you are going to put the relationship between radian and revolution. We know 2 pi radian is equal to 1 revolution. Now, why did I put radian down? Because I want this radian to cancel with radian so that we have revolution per second. And then you agree with me that 2 can go here, we have 10. And that means W is going to be equal to 10 over pi, now revolution per second. So gentlemen, what is our K? If you compare both of them, this means K will be equal to 10 over pi. Is it clear, gentlemen? Yes, Mr. Amir, your question.
You can just convert from feet to radian, like put 30 over 3 over 2, and then you will get the radian.
No, feet is a linear measurement. It is a linear unit. A revolution, radian, and degree, they are about the circular, okay, the angle measure. So we cannot convert feet directly to radian measure. You get my point? What we are converting is revolution. Look at the question again. I did not touch the feet. The feet is here. We are talking about revolution per second. So we are converting this radian to revolution. We did not convert to feet. Do you understand now?
Yes, you got the radian from the feet, right?
We got the radian.
Okay, okay.
We did not get the, oh, okay, yeah, maybe I get you, I get where you are confused now. Maybe I should explain to you, okay? Shufina. What V divided by R, okay? Now what is V? V is going to be 30 feet per second. Now the radius is equal to 3 over 2 feet. Now Shufina, feet cancel with feet already. So there is no feet again.
And then you get the radian.
Then you get the radian. Thank you.
Okay, clear.
Yeah, Mr. Tamir, your question?
Yes, here in the angle of speed in 1 over 2 pi radian. How can a difference between 2 pi over 1 and 1 over 2 pi?
That is why I explained to you this way. I said, you know, here you don't want radian here. Look at it. Let me tell you. You say 20 radian per second. That means in 1 second. Now, how do you know if you have made mistake or you are correct? You don't want radian. Lazim, you have to put it down. Right? And you know 2 pi radian is equal to 1 revolution. That is why we put it down, so that they can cancel each other. Now, if by mistake you put it up, if you put 2 pi radian here, and here you put 1 revolution, you can see they not cancel. This is going to be radian square. So that will tell you that you are wrong.
Yes, if I need the revolution, I put 2 pi over 1, right? Like this.
Mr. Tamir, you know, the easy way to always remember, you don't need to memorize anything. I have 20 radian per second. I don't want radian. What do? I want to cancel radian. Lazim, you have to put radian here, that, so that it can cancel with the one that is up. Are you with me now? And the relationship will be 2 pi here, and this is going to be 1 revolution. Is that clear now?
Yes, yes.
All right. Okay, gentlemen, let us proceed to the next question. Okay, we have here, the question says, in the adjacent figure, if the angle of depression, we know what is the angle of depression, right? Angle of elevation is the angle for looking up, and the angle of depression is the angle for looking down. If the angle of depression from the top of a flagpole to the top of a 10-meter building is theta. So we are talking about the angle here. Let me draw horizontal line, gentlemen. So the angle here is theta, the angle for looking down. That is the angle of depression. Now you can see that this building is 10 meters long. So here, let me draw another horizontal line here. So the two lines are parallel, so lazim, this was also going to be theta. Now, the distance from here to here is going to be also 10 meters because the height of this small building is 10 meters. Now, the question gives us secant. It says secant of theta is equal to 5 over 3. Gentlemen, we know that the secant is equal to r divided by x. So by Pythagoras, we can find y, right? But because we are talking of acute angle, that means y will be positive. If you don't know, gentlemen, to find y, we are going to use the relationship r squared minus x squared. And this is going to be a famous side of a right angle triangle, which is going to be equal to 4. So, gentlemen, let us call from here to be x, for example. Let's call this one h. So if I find the h, I can find the height of the length of the flag. That is going to be h plus 10 meters. So what is going to be the h now? We have opposite over the adjacent. We are given the distance between them to be 150, right? So we know that opposite over the adjacent, that means h divided by 150 is going to be equal to tangent, right? Tangent of theta. I'm talking about this angle. And tangent of theta is equal to y over x. Now, from the question, we know what is y. Y is 4 and x is equal to 3. Right? So what do I do, gentlemen? H will be equal to 4 multiplied by 150 divided by 3. And that is going to be 50 multiplied by 4, and that is going to give us 200 meters. This is the h, but that is not the length of the flag. So therefore, the length of the flag will be the h plus 10 meters, which is going to give us 210 meters. Now, in this type of question, the question is straightforward, but care must always be taken that this part is separated from this part. So when you have the answer, you still have to add 10 to it to get the length of the pole. Yes, sir, your question.
Yes, doctor. Can I draw another small triangle and put the adjacent 3 and
yes, you can do that.
Yeah, okay.
Abdullah.
How did you locate the angle of depression in the
angle from the flagpole? If this is the flagpole, okay, the angle of depression is the angle of looking down. That is the angle formed by the horizontal line, always by the horizontal line. Whether you are talking about angle of depression or angle of elevation, it is the angle formed by the horizontal line.
Okay, it's clear now. Thank you.
All right. Okay, gentlemen. Question number 10. Here, the question says if alpha is the reference angle of this, and beta is the largest negative coterminal angle of this one, what is alpha plus beta? So let's say our angle theta, let's call it theta for instance, is equal to minus pi over 6. Now, before you can find
you have
the
to
reference
add
angle, you have to find
pi.
the coterminal. Now to find the coterminal, so make it easy for us. This pi over 6, we know this is going to be 30 degrees, so we can write it as minus 30 degrees. Why am I doing that? Because the final answer is in degree. So now, what is going to be the coterminal? The coterminal will be equal to minus 30 degrees plus 360 degrees. So the coterminal angle is going to be 330 degrees. 330 degrees, that means we are in quarter number 4, right? Now, what is the reference angle in quarter number 4? Reference angle theta dash will be equal to, in quarter number 4, we say 360 degrees minus 330 degrees. So the reference angle is back to 30 degrees again. And what does this one mean? It means the alpha is actually equal to 30 degrees. Now, let us go to beta. For the case of beta, let us call the angle theta again, 670 degrees. Now, we are going to find the coterminal angle. But the coterminal we are looking for, gentlemen, is the largest negative coterminal. When we say the largest negative coterminal, what does that mean? You are looking for the angle between minus 360 degrees to 0 degree. That is what you are looking for. The largest negative coterminal will be between minus 360 and 0 degree. So if we subtract 360, the answer will still be positive. So in other words, I am going to subtract 720 degrees. So we are going to get minus 50 degrees. So therefore here, beta will be equal to minus 50 degrees because we are talking about negative coterminal. So gentlemen, alpha plus beta will be equal to 30 degrees minus 50 degrees, which is equal to minus 20 degrees. Is it clear, gentlemen? Okay. Okay. Mr. Tamir?
No, I understand now.
All right. Amar.
Yes, doctor. If he said the smallest coterminal, what should we do?
The smallest. If he says the smallest, it has to put either positive or it has to put positive. So when he says the smallest positive coterminal, that means you'll be looking for angle between 0 degrees and 360 degrees. Smallest positive coterminal. Angle between 0 and 360 degrees. Largest negative coterminal between minus 360 and 0. Can you see the difference?
Yes.
All right. Okay, gentlemen, 11. Here, it says we have the tangent, we have the secant, and we are given sine also. And this is going to be equal to, so we are going to have a trigonometry on the right side, which is cosine only of alpha. So how do we find this alpha? Please pay attention. Here we have 17 pi over 4. The first thing to do is to find the coterminal angle. The coterminal angle, let's say this is theta. Theta is equal to 17 pi divided by 4. What is the coterminal of this? 17 pi over 4 minus. We go around the circle more than one time. How do you know how many times you go around the circle? You see 17 pi divided by 4. Thank you. And that is going to be equal to 4 pi. So this one is always going to be, you are going to always subtract even number, not odd. So this is going to be minus 4 pi. And the result is pi over 4. So because it is coterminal angle, we can rewrite this one as tangent of pi over 4 directly. Now, we know that secant is an even function. We can throw away the minus here, and we can say this is going to be secant of 120 degrees. And here, let us not touch it. Let us leave it as it is, minus 230 degrees. Now here, we know tangent of 45 degree, pi over 4 is 45 degree. That is always going to be equal to 1. Now here, we are in quarter number 2. 120 is in quarter number 2, where 230 is in quarter number 3. So in quarter number 2, secant, is it positive or it is negative? You will agree with me that secant is actually negative in quarter number 2. And in quarter number 3, sine is also negative. So what will I do now? I am going to bring this negative down. So we have minus. So we have secant. Secant of what? This is quarter number 2. We are going to find the reference angle in quarter number 2. Theta is equal to 120 degrees. The reference angle will be 180 degrees minus 120 degrees, which is equal to 60 degrees. So we have secant of 60 degrees. Now, there is often a common misconception here. Many students often believe that whether you are talking about secant or cosine, because you say cosine is an even function, it will always be positive. No, that is not true about the reference angle theorem. So we need to be very careful there. Now here, what do we do next again? You see this minus here, we come down. So here we have minus, and then the bracket open. We have minus again, sine. What will be the reference angle? Theta is equal to 230 degrees. In quadrant number 3, the reference angle is going to be the angle minus 180 degrees, and that is going to be 50 degrees. So here we have a sine of 50 degrees. Of course, you agree with me that sine of 50 degrees is not a famous angle. Let us continue. So here we have 1. Now, secant of 60 degrees, that is going to be the reciprocal of cosine of 60, which is 1 over 2, and that is going to be equal to 2 directly. Now here, we can say minus times minus, that will give us positive, plus sine of 50 degrees. Now this is 1, and this is minus 2. Combine them together, we get minus 1 plus sine of 50 degrees. Now when we check the answer, we see that in the answer there is no sine, rather we have a cosine. And this is when we use the property of the cofunction. What is that property we are talking about? We say, gentlemen, sine of theta is equal to cosine of 90 degrees minus theta. So if we say sine of 50 degrees, that will be equal to cosine of 40 degrees. So we can rewrite this one as minus 1 plus cosine of 40 degrees. And that is what we are looking for. So if we compare now, you will agree with me that k will be equal to minus 1. So therefore, k is equal to minus 1. And then alpha is going to be equal to 40. Of course, it is supposed to be 40 degrees. But you can see here, already there is a degree here, and there is a degree here. So that means alpha is going to be equal to 40. Now, the question says, what is going to be k plus alpha? Therefore, k plus alpha will be equal to 39. Do you understand it, gentlemen? Questions? Yes, Ryan.
Yes, it's clear.
Yes, Doctor,
All
one
right.
question. How do I know if a radian angle has to have, like, I have to find its coterminal? How do I know if I have to find its coterminal?
Okay, let me tell you one thing. In any question you see in section 5.3 or 6.2, You see, whenever you have any angle that is akbar 90 degree, any angle greater than 90 degree, you must always find the reference angle. In other words, what I'm trying to say, every angle that you find, you must convert it to between 0 and 90 degrees using the reference angle theorem. Always, for any question you want to solve. That is the secret. Convert each one of them to angle between 0 and 90 degrees. Once you do that one, life is easy. Now, you see all the angle here we have converted to angle between 0 and 90. But what is the method of doing that? We have to use the reference angle theorem. But the reference angle theorem, when the angle is negative, for example, if you have the angle to be less than 0 degrees, what do? First, you have to find coterminal. You have to first find the coterminal angle. After the coterminal angle, then you find the reference angle. Similarly, if you have the angle that is greater than 360 degrees, first you must find the coterminal angle. You must always find the coterminal angle. Then after finding the coterminal angle, you can find the reference angle. So look at it. Any angle that is less than 0, find the coterminal, but then find the reference angle. Angle greater than 360, find the coterminal and then find the reference angle. Is that clear?
Yes, doctor. Thank you very much.
You're welcome. Okay, now 12. Here the question says we have 2 sine of beta equal to 3 cosine of beta. Of course, this question we can solve it in different form. Here we can decide to divide both sides by sine, or we can divide both sides by cosine. The choice is ours. If we decide to divide both sides, for example, by cosine, so I can say 2 sine of beta divided by cosine of beta. To make it tangent is going to be equal to minus 3 cosine of beta divided by cosine of beta. Cosine, we go with cosine, and then we have 2 tangent of beta equal to minus 3. And then tangent of beta is going to be equal to minus 3 divided by 2. Now, please pay attention. Here, we know what is tangent. Tangent always we write it as y over x. But here we have it to be negative. So tangent is negative in which quadrants? That will be quadrant number 2 or quadrant number 4. Quadrant number 2 or quadrant number 4. Now, let us go here. The question gives us information also about sine. It says sine of beta is greater than 0. That means sine is negative. Sorry, sine is positive. Sine is positive. Now here, which angles are sine positive? The quadrants will be quadrant number 1 or quadrant number 2. Now, which quadrant is common to both of them?
Y is
number
positive.
2. Sine positive. The question tells us the sine of beta is positive from the question because it says akbar 0. Right? Greater than 0 means positive, right? Okay, now, so that means our angle is in quadrant number 2. So we can say therefore beta is in quadrant number 2. Now we can answer the question now in 2 ways, either by picture or by using one of the properties we know. Let us start by the picture and then we try the other method. We have a 2-dimensional coordinate system and this says this is the y-axis and gentlemen, this is the x-axis, and we are in quadrant number 2. So here we draw this one to meet at 90 degrees. So from here to here is going to be our beta. Now we have x to be equal to y has to be positive. So y is 3. Why is y positive? Because we are in quadrant number 2. And x is going to be negative, minus 2. Now if we use Pythagoras, gentlemen, we know that r is going to be equal to root of x squared plus y squared, right? X squared is going to be equal to 9, and x squared is going to be equal to 4, and y squared is going to be equal to 9, which is going to be 4 plus 9, and that is going to be root of 13. So here we have the r to be equal to root of 13. Now the question is asking us to find secant of beta. So secant of beta is going to be equal to r divided by x. And what is r? It is going to be root of 13 divided by x, and x is going to be equal to minus 2. So let's put 2 here and the minus outside. So this is our answer. This is one way when you draw the picture. If you do not want to draw the picture, once we know that we are in quadrant number 2, we can answer, because there is a relationship between secant and tangent. There is a relationship between secant and also the tangent. What is the relationship? We know that the secant, squared of beta is equal to 1 plus tangent squared of beta. So this will be equal to 1 plus, what is tangent given to us from the question? We have minus 3 over 2. So we put here minus 3 divided by 2 all squared. And this is going to be equal to 1 plus 9 over 4. Okay, when you take the LCD, this is going to be equal to 13 over 4. Therefore, our secant will be equal to, of beta, is going to be equal to plus or minus square root of 13 divided by 4. But we are saying that beta is in quadrant number 2. And in quadrant number 2, secant is negative. So we are going to take the minus here. So when you simplify, that means the secant of beta will be equal to minus root of 13 divided by square root of 4, which is 2. And that is the alternative answer.